Let's take a look at some probability practice for independent events. So let's do a little bit of practice together. The first question says, in 2001, the M&M company came out with a new color for M&Ms. In the US, 42% of the respondents wanted purple, 37% wanted teal, and 21% wanted pink. And so the first thing I would do before looking at any of these questions is to make sure that 0.42, which is purple, plus 0.37, which is teal, and again I'm just writing these as decimals, plus 0.21, which is pink, I want to see what they add up to. Because if they add up to 1, then I know I'm okay. And in this case, if I add these values, I do get 1, so I know I'm okay. If I were to get a value greater than 1, then it is possible that they allowed people to choose more than one color. If I got a value that was less than 1, it's possible that some of the responses were not included. So I did get a 1, so I'm okay, so now I'm going to get started on these questions. So first, what is the probability that a respondent selected at random preferred either pink or teal? So here's my keyword or, and remember or uses that union. And so essentially what I'm saying is I want the probability of pink union teal. And union tells me that I'm essentially just taking pink and I'm adding the probability of teal. And so if I took the probability of pink, which is 0.21, and I added the probability of teal, which is 0.37, I would get 0.58. Now, in this case, I could also look at the fact that purple is the only other option. And so I'm saying if they wanted pink or teal, it's the same as the probability of not purple. And so I could have just taken 1 minus 0.42 and notice I still get 0.58. So I could have done that first question either way and still gotten the correct solution. Again, on that first one, remember, this was only one event occurring. Only one event occurred, and therefore I knew that I wouldn't be multiplying. So now let's take a look at our second question, and it says if we pick 2 respondents at random, well, that right now tells me that I have 2 events. And when I have 2 events, I'm probably going to be multiplying. Not probably, I'm going to be multiplying. And this one says what's the probability that they both said purple? So I'm going to say the probability of purple and purple means the probability of purple times the probability of purple. And again, we're assuming these are independent events because it's a very large sample size. So purple is 0.42 and purple is 0.42. And of course, I could have written that as 0.42 squared. But for the sake of noticing that this is the first event and this is the second event, I'll leave it just like this. And when I multiply those out, I get 0.1764. So here I'm going to 4 decimal places. Next question, the probability that a respondent would not pick purple or pink. So again, I could do this one of 2 different ways. What I'm looking for is the probability of pink or purple not. So not pink or purple. In this case, we know that's the same as the probability that they did pick teal because that's the only other choice. So that's the easy way to go about it, is to just take the probability of teal. Otherwise, I could have found 1 minus, and then I would have added pink, which is 0.21, and added purple, which is 0.42, and subtracted that from 1 because it's a not question, which makes it a complement. And again, I would have gotten the same result because when I added these two together, I would get 0.63. Looking at our next question, now we're looking at 3 respondents. So again, that means 3 events. So I'm multiplying again. What's the probability that none picked purple? So a lot of people struggle with this one, or they get this one and the next one confused. But essentially what I'm saying here is I have 3 events occurring, and the first person did not pick purple. Let's see if I can spell correctly. Not purple. And the next one did not pick purple, and the next one did not pick purple. So what are those probabilities? Again, when I'm using and, I'm multiplying. So essentially I'm taking not purple times not purple times not purple. I'm not going to write that out because that's just a lot of extra writing. But essentially what I can do is I can take the probability of not purple and I can take it to the 3rd power because it's happening 3 times, 1, 2, 3. So in this case, I can say 0.58 to the 3rd, which is 0.1951. So again, I could have written out 0.58 for not purple, 0.58 for not purple, 0.58 for not purple, and multiplied it, but that's the exact same thing as taking 0.58 to the 3rd power. Let's look at our last one. This is one of the hardest ones. A lot of people really struggle with this. So it says if we pick 4 respondents at random, so again 4 respondents means there's 4 events, which means I'm going to multiply. It says what's the probability that at least one of them picked purple? So that at least makes things really tricky. And here's why. I know I have 4 people, 4 respondents. And it could be that I had purple, not. And it could be that I had not and purple and not and not. And it could be that I had not and purple and not, or not and not and not and purple. Or, and that's just for 1. Then I could find the probability that 2 people said purple. So that would be like purple, purple, not. And we could do this all day and it would get really tiresome and be horrible. So instead what I'm going to do is I'm going to find the probability that nobody picked purple, which is the, if I did all of these, it would be none, not. I want to find this probability because in this probability, at least 1 did pick purple. And if I continued my list with 2s, someone did pick purple. And if I continued my list with 3s, someone did pick purple. And then I would have a line that was purple, 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 and that would all be in here as well. And the only other option is nobody did. And so that's what I want to do, is I want to take 1 minus the probability that nobody did, and that is going to give me the probability that at least 1. So let's do that. What's the probability that nobody picked purple? Well, we kind of looked at that in our previous question. And here I'm going to put P at least 1 purple. And that's going to be 1 minus the probability of no purple. That's the big idea. So how am I going to calculate that? Just like I did in the previous question, where I'm going to say the first person didn't pick purple, because that's not purple. and then the second person didn't pick purple, which would make that 0.58 squared, and the third person didn't, which would make it 0.58 to the third, and the fourth person didn't, which would make it 0.58 to the fourth. So this is the probability not purple, not purple, not purple, not purple, and if I multiply that out and then subtract it from 1 because order of operations is important, then I would get 0.8868. And that is my solution, is 0.8868, which is the probability that at least one of them picked purple. So here is another set of practice for you. It's similar to the ones we just did on the other page, but take a few moments to see how you do on these. And I'm not super concerned about your notation. It's important that you recognize the notation, but this being a beginning stats class, if you just use the word and or instead of union and intersection, then that's just fine with me. But do go ahead and try these. They're similar to the last ones. And then once you've tried them all, then please press play to see how you did. So here's my practice. And again, I'm going to, right before I start, make sure that 0.3, which is the US, plus, 30% is Japan. 40% is US. So 0.4, which is US, 30%, which is Japan, 10%, which is Germany, and 20% other. And I want to make sure that this all adds up to 1. And of course, when I do that, yes, it does. So now that I know that, I can continue with these questions. So the first question says, what is the probability that a car is not US made? So again, two ways to go about this. The easiest way to find the probability that it's not US made, so again that's the complement, is to take 1 minus the probability that it is US made. And in that case I would get 0.6. The other way, of course, is to take the probability of Japan, Union, Germany, Union, other, and add all of those together. So 0.3 plus 0.1 plus 0.2, and guess what? I get the same answer, but I had to do some extra work. B, it is made in Japan or Germany. So again, or Germany means P, Japan, Union, Germany. And Japan is 0.3, and Germany is 0.1. And so if I add those together, I get 0.4. I see 2 in a row from Japan, so don't get fooled by this one. This one is 2 events occurring. It is, I'm looking at a car, it's from Japan. I'm looking at a second car, it's from Japan. 2 events. So this is probability Japan intersect Japan, which means 0.3 times 0.3, or again, I could just write 0.3 squared, which is 0.099%. Now we get into some that are a little bit trickier. So those were pretty straightforward. Now we're looking at questions like none, or at least, or we haven't even looked at a question like F yet. So again, the first one is none of the 3 cars came from Germany. So again, we're looking at 3 cars, which means 3 events. And so I'm going to say the probability of not Germany and not Germany and not Germany. Now, because all of these probabilities are the same, again, I can basically take it to the 3rd power. But first, let's think about what's not Germany. Germany is 0.1, and so 1 minus 0.1 would be not Germany. And it's happening 3 times because it's not Germany, not Germany, not Germany. So 0.1 or 1 minus 0.1 to the third, which is 0.9 to the third, which is what we would expect, which is 0.729. Next one, again, this is an at least question. At least are a little bit tricky. So it says at least one of the 3 cars is US made, which means I'm finding the probability, I'm taking, 1 minus the probability that none are US made. And so that's the calculation I'm going to do. So I'm going to take 1 minus. Now what's the probability that none are US made? Well, if it's US made, it's 0.4. And if it's not US made, it's 0.6. So I've already done that calculation, so I'm just going to use that 0.6. And I'm taking that to the third power. So I could, if I wanted to, write the 1 minus 0.4 and then that quantity to the third, but I don't want to get crazy with quantities and all of that. So now I'm taking 1 minus 0.216, which is 0.784. And that is my probability. At least one of the 3 cars is US made is 0.784 because I'm taking the complement that none of them were US made. Last one, we haven't looked at one like this before, but this is saying the first Japanese car is the 4th one that I choose. Okay, so I'm saying I have to take the probability that it's not Japanese and the probability that it's not Japanese and the probability that it's not Japanese and the probability that, yes, on the very last one, it is a Japanese car. And so, not Japanese is 0.7, not Japanese is 0.7, not Japanese is 0.7, Japanese is 0.3. Now, I would write this as 3 times I didn't get a Japanese car, and on the last time I did. So now I have 0.7 to the third times 0.3, and that answer is 0.1029. And that is my solution.